Hello friends, welcome back to my YouTube channel Infinite Knowledge, and I am back again with another great video and another great projects that will be helpful for your final year BTech project or your final year diploma project as well. So what is it? So it is a digital over voltage and under voltage protection using Arduino UNO, and with is IoT base. So actually, you had watched this my YouTube shorts, and which is a very popular, and you all requested just to put a video regarding to the over and under voltage, over and under voltage protection circuit. So here is the video, and it has the voltages in this. Regarding to the over and under voltage protection using Arduino UNO. If you want email alert, you can install ESP32. ESP32 is a microcontroller, and that gives us the email alert or a WhatsApp alert or a Telegram alert, whatever you want. So, and this is the simulation that I had done in the Proteus software, and this is the program. So each and everything you will get in the description box, starting with the basic of simulation. This PPT is also available in the description box. We are going with the basics of these projects, and then we are going to high advanced, in which we are talking about the IDMT characteristics in voltage as well. So I have developed the IDMT characteristic in voltage as well. Just that I have already made a video of over voltage protection, uh, not a over voltage, it's the over current protection using Arduino Uno. So this is the video in which a totally over current relay I had developed in in hardware as well as in Proteus simulation. So here we are going to one step forward, and now we have developed over and under voltage protection using Arduino Uno. And just I am giving you the brief, then we will check the simulation and the hardware. So why we call this a digital or numerical? Because it's a digital in which the electronics components are there. There is no any mechanical components, no any electromagnetic components. It is a totally electronics component like a capacitor, resistors, and each and everything. And that's why you can consider it a digital or a numerical relay. And if you are interested what is the coverage of this video, so this thing will covered in this PPT as well as in the video, and each has some slides, and we will understand each and every steps and each and every thing in the very brief. Okay. So this is just a basic of introduction. So voltage protection is a very necessary protection. Why it is very necessary protection? Because if your voltage is higher than your restricted limit, then it will definitely damage your equipment and sometimes might get fire also. So that's why voltage protection is very necessary, even though it is a household equipment. Even in household equipment, voltage protection is very necessary. As per IEC standard, plus minus 6% voltage variation is tolerable. Hence, there is a chance to get over and under voltage in the grid itself. So that's why even your grid also your voltage varies from this range. So voltage is not even fixed. If you are getting in voltage, if you are from India, they claim that we are getting 230 volt. But if you check the voltage in your house by using a multimeter, you might get sometime it's a 250 or sometime lower than the 230 or it's an 210. So this voltage might get varies. So you cannot say the voltage is fixed, so that's why you are getting continuously 230 voltage. It is not possible. It's ideally not possible. You are getting enormous voltage variation, and sometimes lower voltage is also harmful to your equipment because it cannot work as its efficient limit or satisfactory limit. And over the period of time, if your equipment has some electronics component, that might get damaged due to lower voltage. Okay, so over and under both protection are necessary, and here we have developed the IDMT characteristics. Why IDMT characteristics, and what is the importance of this IDMT characteristic? So if you are know the overcurrent relay, or if you have gone through my overcurrent video, you will understand that IDMT is the inverse characteristic. So as your current is increased, your time to trip, this is the time. So as your current is increased, like is your current is increase, your time to trip is decrease. So it's a exponential characteristics we are getting. So inverse, that's why we have considered the inverse characteristic. So this similar characteristic I have tried to develop here also, because there is no any IEC standard for the IDMT characteristics specifically for voltage protection. IEC standard is only specified for the current protection, but I have developed similar logic, similar inverse characteristics for voltage as well. So if you consider the voltage and if you consider the time, so we I have developed the formula, I have developed the program which is specifically protect by using the IDMT characteristics. Okay. So what it mean, if you are considering the over voltage, so as your voltage is getting high, your time to trip is decrease. Similarly, under voltage, under voltage condition, so as your voltage is going down, then also your time to trip is a decrease. So this thing we will understand in brief in the next slides and even in the simulation. So if we go on through the simulation, you will be very clear about it. And this is the types of relay. What is the type of relay? This is the three types of relays: static relay, numerical relay, and the electromagnetic relay. Obviously, this is the three types of relay. This is obsoleted nowadays. These two are in the trend. Okay. So by using Arduino UNO and IoT programming device, we can make the digital standard inverse over and under voltage protection relay. This is the name of our project, and that is a part of the numerical relay. Okay. The standard inverse characteristic of the relay response inversely proportional to the voltage magnitude and the operating time, as we understand here, inversely proportional to the voltage magnitude. Okay, and ensuring the efficient protection different fault level. So this is a very basic understanding of our project. What we are trying to do, what we will see in the next slide. So now we are going forward further. Okay, so now we are checking the working principle of this project. So how it is working. So it is a very basic principle. What we have Arduino UNO, that is our processor, and we are getting the signal from the sensors. The sensor which I have used is we will see ZMPT101B. This is the name of the sensor, or you can see is a voltage measurement sensor, which is used to measure the voltage, and that is connected parallel to our load. So just going to the principal, numerical relay is the latest industrial 4.0 based advanced microcontroller based IoT relay, and it's faster, accurate, reliable, and compared to the electromagnetic relay. Electromagnetic relay is not much more reliable because it takes some time. There is an enormous amount of mechanical component, and which might due to that we are not getting the satisfactory output. And as the time passes, due to depreciation of the and degradation in the that component, we are getting the lower accuracy. Okay, so that's why we have developed the numerical relay and very advanced relay, and that is used in the industrial 4.0. Industrial 4.0 is the latest trend. We are in the latest consideration in the industrial segment, and all the industries are now working on this level 4.0. Basically, in this relay, voltage sensing sensor have been installed, and which sends the not a current, which sends the voltage as an analog value, and then it is converted into a digital signal. Okay, the process to check the voltage value whether it is in the limit or not. If the voltage is more than the over voltage setting, so what you have to do, you need to add voltage setting and current under and over voltage setting. So whenever we check the simulation, you will get to know about very clearly. So uh, you need to add over voltage setting, so voltage at which or more than that voltage level you need some protection. Okay, so that is over voltage setting, and there is a time multiplier setting also. So time multiplier setting is how fast your relay shall be tripped. So that is used to time multiplier setting, which is vary from 0.1 to 1. So you need to set this value also. So if you set 1, you are getting more time to trip, and if it is zero point 0.1, you are getting less time to trip. So faster tripping is with this point 1. Okay, so similarly under voltage also, so you what you have to add whenever you start the simulation, or whenever you are trying to run or make the hardware, you need to add some values over which you need to protect your circuitry each and every time. So you need to add over voltage setting and TMS for it, time multiplier setting, and again under voltage. And so we will check how to add in the simulation part. Just take it aside, basic block diagram. So this is a 230, or you can say 220 volt supply. And parallelly supply source we have installed ZMPT101B, which is a voltage sensor which sends some data, and that is given to the Arduino UNO. Arduino UNO is a LCD display which is continuously monitoring the voltage that's measured by the ZMPT101B. There is a SPDT relay, and which helps to disconnect the load whenever any abnormality happen, or whenever the voltage range is threshold limit that we have compared to added value. Okay, and this is a keypad also. The keypad is used to add some values, and that's taken the Arduino, and continuous monitoring or some display data. Display the data we have installed the LCD. Okay, so it's a very basic. This is a Arduino Uno. This is a ZMPT101B voltage sensor, which is specifically used to measure the AC voltage, and this is a relay isolated circuit whenever any abnormality has happened. Okay, so now we are going to the simulation part, so you will get to know about everything very clearly. So
Okay.
this is a simulation part, and just I have run this simulation. Okay, so yes, whenever I start this simulation, so just I am giving you the brief of this. This is a connection. This is Arduino. You know, this is a keypad. This is some LED which is used to indicate on which level the microcontroller get tripped, and if it is trip on over voltage, then I think this will glow, and if it is under voltage, I think this orange LED will glow. Okay, and this is the display, and this is actually ZMPT101B is not available in the Proteus software. That's why I have simply developed this 5 volt circuitry, and by this way we are getting some voltage. So first what you have to add over voltage. So this is a voltage value over which you need to protect any circuitry. So if you are talking about the protection of the circuitry, what you have to consider, just wait, I am just giving you some very uh, great explanation about it. At this point, you need to understand. So, what is this one tells us? This is a formula. This is a formula, and according to that way, we are calculating the time to trip. It's time to trip because it is a correct IDMT characteristic that a particular time or particular voltage level, what time required to trip the circuitry, that defined by this particular voltage level, this time is required to trip. So this time is defined. So each and every level there is a time to trip is different. Okay, and that is calculated by this formula. And this 5 is more that I have added to get proper timing, because there is no any standard, there is no any standard for the voltage protection. The standard formula is used for only for current protection, but I have developed for the voltage protection, and which is a very satisfactory work. Okay, so not that if the measure value is 1.08 times the over voltage setting, so if I add 250 as a over voltage, so 250 into 1.08, so what it will be, I think it will be uh, two. Just let me check. If I multiply 250 with 1.08, it's a 270. Okay, so if my voltage is more than 270, what I have to do, I require instant tripping. So no matter what is time, it should not wait for any time and give me the instant tripping whenever voltage is higher than 1.08 time the over voltage range. Similarly, here you need to note that if my current, or not a current, if my under voltage setting, so for a 230 volt protection, what you are usually added, we are usually added 250 for over voltage protection, and 210 for a under voltage protection, as per plus minus 6 percentage variation. This is a IAC standard variation. This is our voltage that is come in our home, and which get vary this voltage level. This is a tolerable range. Plus minus 6 percentage voltage might be vary in our home as per IEC standard. Okay, so we have considered maximum voltage level this. So if my voltage is increased from this limit more than 250 volt, then my time to trip calculation will start, and after this completion of this time, the tripping shall be generated. And if my voltage is more than 270, then it should not wait for time to trip and give the instant tripping. Similarly, for 210 volt, this is under voltage limit. So under voltage limit you need to multiply by zero point 0.9. So 210 into zero point 0.9. So it will be, I think, 1.89. Not a 1.89, 189. Okay. So if my voltage is reduced more than 189 volt, then I want a instant tripping. No need to wait for the time to trip. It shall be generate instant tripping. So we will check all the things. We will check the timing also. We will check the instant tripping also in the simulation. But this thing you need to be very clear about it. This is actually calculation and which is very helpful to understand the IDMT characteristics, inverse characteristics. Okay. So until now, I think you are very clear about what is the equation and what is the under voltage equation and what is over voltage equation. So now we are go further to the simulation part. First, we will check the simulation and how these standard inverse characteristics you will get. That thing we will also check. So just I am go back to the simulation part. And this is the circuit that you will get in the description box. It's a Proteus simulation circuit, and whenever I start the simulation, what you have to add, so you can see here add over voltage. So we need to add over voltage. Okay, so what why we have add 250 voltage, we will understand in the next in next sometimes. Then add tms was 1 then under voltage, so 210. So usually we are considering the voltage 250 for over voltage and 210 for the under voltage. In India, usually you are getting 230 voltage and with plus minus 6% voltage variation. Okay, a TMS is also I have added one. So you can see here voltage is 230 voltage. So I think the system is under the normal condition, because voltage here is 230 voltage and which is in the limit in between 210 and 250. Okay, so in between 210 voltage or 250 voltage. So whenever I press this switch, it means it starts the our input supply, and that's why you will get some error or some under voltage tripping error, because your input voltage shall decrease. You can see at an instant, at an instant I am getting under voltage tripping, and specifically there are two relays, one orange relay which is used to indicate the under voltage tripping, whereas one green relay which is used or which will glow when the over voltage tripping is happening. So now we will this is a basic understanding, and why this over voltage stripping is happened and how it's work. And for that you need to understand these excel formulas. So this is the formula and this is the excel file that you will get in the description box. So this is a voltage that we have added over voltage range. This is a 250 voltage. You can add any value here, and if you add any value according to that way, your voltage will be changed. You can see here this is for our over voltage excel, and this is 250 voltage. Add the value of over voltage, so you can add any value. If you want 500, you can add 500 also. You can add 260 also. Okay, and 250 is usual voltage range that we have considered. Why 270? Why this is 270? It is a voltage which is a 1.08 times your input added voltage. Okay, so if you add 250, so what is meant that if your voltage is increased from 250, then you shall get a tripping in certain amount of time, and this time is vary according to our IDMT characteristic. So you can see here, if your voltage is 251 for a constant time, or if your voltage is 251 which is constant, then after 350 seconds you will get the tripping. Okay, and you will get the over voltage tripping. Similarly, as your voltage is increased, your time to trip is decreased. That's why you are getting inverse characteristic like this. TMS is 1. This TMS is 1. This thing. Okay. So here we have considered the TMS 1. You can check here. TMS is 0.8, TMS is 0.5, and TMS is 0.2. So as the TMS is increase, your time to trip is decrease. You can see here very clearly for 251 voltage, for 1 TMS your tripping is 350 second, for 0.8 it is a 280, for 0.5 it is a 175, and 0.2. So as your TMS is decreased, your time to trip is also getting decreased, and after a certain amount of time, and when it is a 271, you are getting a instant tripping. Why it is a instant tripping? Because it threshold the limit, which is a limit 1.08 times. If your voltage is increased more than certain limit, then you need a sudden tripping. Okay, so that's why this is happening and this is considered. So in this voltage graph, over voltage graph also, you can see after certain limit, or when your voltage is increased more than 270, and you are getting the instant tripping. That's why this notch is formatting here. And yes, it's your TMS is reduced, your time to trip is reduced. Okay, again for the under voltage also, under voltage we have considered 210 voltage, and in under condition also, if your voltage is reduced below certain level, then again you need a instant tripping. So that's why its range is 0.9 times your added value. So 210 into zero point 0.9. That's why you are getting a 189 voltage. So if your voltage is further reduced from 189, you are getting the instant tripping, and that notch will be formatted. Okay, here it's a instant tripping directly 0. And as your voltage is reduced, your time to trip is reduced. Okay, so here your as your voltage is increased, your time to trip is increased. As your voltage is increased, your time to trip is reduced, and in under condition also, as your voltage is reduced, your time to trip is also reduced. Okay, and that's why it's formatting IDMT characteristics, inverse type characteristics. So I think everything is very clear for you, and yes, this is also I have covered, and just wanted to explain you in the simulation how you can get it a tripping. So now it is a 5 voltage, but if I reduce this voltage for certain low level and check whether in certain time we are getting the proper tripping. Okay, so now it's a under voltage condition, and under voltage condition we need to check this file. Okay, for under voltage condition we need to check this file, and according to setting we will check whether the time to trip is actually similar to our calculation or not. Okay, so just I am go back to the simulation part. So I have started the simulation, and 4.2 voltage, its mean voltage is lower, input is lower, so under voltage condition is created. So add over voltage, so usually adding 250. And what is the time to trip? We have considered 1 TMS. You can consider any value. Actually 0 0.1, 0 0.2, 0 0.3. Actually why this happening? You need to press any one key. So whenever I start the simulation, you need to add 250. Okay, and if you want to add zero point 0.5, then you need to press this. If you end to end 0.7, if you change anything, then it will be changed. So you need to be very clear about it. You need to press only one key, and usually we have considered TMS as a 1. So 250, then TMS is 1, then 210 under voltage level, below which we need to tripping, we need the tripping. Okay, so as you said 190, 193. So you can see here for a 193, I think we shall get the tripping in the 16 seconds. So we need to wait the 16 seconds, and I think in 8 or 9 seconds, because this simulation is continuously running whenever we are adding data also. So just wait, I will explain you once again. So after 16 seconds, we shall get the under voltage tripping, and this LED will glow, orange LED. Okay, so that at that moment we get the uh, tripping on the under voltage strip. So now we will check whether we are getting a tripping in the 16 seconds or not. So what we have to do, we have to add all the data. So as I start the simulation, you can see here the timing is started. So I am just adding the data. Okay, then TMS, okay, 1, then 210. So now after adding this under voltage stripping, whenever I start the simulation, at the same time this calculation will start. So at 10 second, I press this plus sign. Okay. So after exactly 16 second, it means in between 26 or 27, we shall get the tripping. So we need to wait and just check the seconds. So why I am explaining this thing, because I wanted to show that our calculation and our program is very working very clearly or very satisfactory, and actual our calculation, it is actually generated a tripping. Okay, so you can see here exactly 28, or it means after 16 to 17 second we are getting the output. Okay, so and which is very near to our actual calculation. So this is how the system is working, and you can create the uh, over voltage scenario also. Okay, so for that I need to add lower voltage. Okay, and then this thing. Okay, and this thing. Okay, so you can see here over voltage trip, because why this sudden happen, because the voltage that added here, or the input voltage, the voltage sensed by the Arduino, it is much more larger than, or you can say it is a 1.08 times larger than added value. So I have add 200, and if you multiply 200 into 1.08, it might be 215. And what is input voltage? Input voltage was 230. So obviously 215 is less than 230. That's why we are getting instant tripping. So what I have added? I have added a 200. So what is a tripping instant tripping level 216, and for a 5 voltage the Arduino is sensing 230 voltage. That's why we get an instant tripping. Okay, so I think each and everything is very clear. Everything is following their particular charts, and if you wanted to create any another voltage, you just need to change the voltage and you will get the that graph also. You need to just change the data here in this, in these two values. You need to change just the voltage and the TMS. So this is how the system is working. Until now I think everything is very clear for you. So we are now switch over to the further IoT logic. So I wanted to just explain you this thing, and this is the ESP32, and this is a microcontroller. This ESP32 is a microcontroller, and this microcontroller is help to this microcontroller have a Wi-Fi capability, Bluetooth capability, and yes, this microcontroller can connect to your mobile phone hotspot also. So by just that way, if you use this module, if you implement or upgrade your project with this module, this is extra module that you need to connect, and this module will give you email alert on tripping, WhatsApp alert, or a Telegram alert. Okay, so you will get this type of alert message on particularly over voltage or particular under voltage also. So you will get email also, you will get a WhatsApp alert also, all you will get a Telegram alert also, whatever you want. Okay, so why this thing is required, why IoT relay is required? Because electrical panels are installed at remote area, so it is impossible to continuously monitor the system. So to get rid of this tremendous situation, we have implemented a logic, or we have implemented the IoT device which give you a instant tripping. So at the time of whenever any abnormality happen, at a similar moment, at the same moment, you shall get an alert on this media. So you will be get alerted, and you will check the system and resolve the problem as soon as possible. So that's why the importance of this small device is very high. Okay, so I think you will understand how the system is work, and each and everything is very clear. So thanks for watching this video. If you have still any query, just comment it. I will definitely reply. And you will get all the data, all the circuitries, all the program, each and everything in the description box. In my email ID, I have given my email ID in the description box. For any type of MATLAB project, electronics project, any type of Arduino microcontroller project, or even hardware project, you can get connected with my email ID. Okay, so thanks for watching this video.